Hello friends, in this video we are going to control the PMSM motor. So this is the PMSM motor and this is the PMSM motor, and to this PMSM motor we are giving this DC machine as the load, and we are coupling PMSM motor and the DC motor by means of a coupler. So here we have few wires coming out of this DC machine and few wires coming out of this PMSM motor. So since this being a three-phase machine, we are using a three-phase inverter, and this box is having three separate inverters. As you can see, this is inverter 1, inverter 2 and inverter 3. So inverter 1 here is used to control the PMSM motor, and inverter 2 is used to control the DC machine here. And both the machines are provided with encoders. PMSM motor has one encoder, and that encoder is connected to the second connection or second terminal available to connect the encoder. So there are two provisions to connect the encoder. The first encoder, the first point is connected to the output of uh, DC machine here. So this is the encoder that we are using in DC machine, and that is connected to the first terminal. And the second encoder socket is connected with the output of PMSM motor. And at the back side of the inverter block, we have the provision to give a DC supply, and that DC supply is coming from the BK precision regulated power supply. So this is where we used to give plus, and this is the point where we used to give the minus. So the thing here is the voltage should not exceed 40 volts, and the current should not go above 5 amps. So that could potentially damage this inverter block or inverter board. So we should be very careful about that. And here we have the option to connect the USB, the board through the USB to the computer or the desktop. So here we are using the uh, laptop. Okay, so we shall control it now. So to control it, we need to open the SCIAMBLE Workbench, and once you open the SCIAMBLE Workbench, you have to go inside the SCIAMBLE server. So if you go inside the SCIAMBLE server, you can find n number of experiments that were developed already. So this could be used for your UG laboratory or PG laboratories, or even it could be used as the base model for research purposes as well. So the experiments are available under three different heads: advanced drives, and basic power electronics. So what we are going to see is under basic drives version 1. And the experiment number 6 is the one which is used to control the PM SM motor. So the first one is the load angle based one. So it is VBF control. And the second one is current control mode. So the current control is the one that we are going to try now. It is a hysteresis controller based control. Uh, with this we can do two things. One is either we can simulate the model or we can run the model in real time. So uh, we are trying to use models or blocks to create the control logic, and that control logic will be used to control this motor that will be dumped into this inverter board. See, this inverter is coming along with a Texas Instrument microcontroller. Okay, so this Texas Instrument microcontroller will drive the inverter IPM based inverter. So to program Texas processor or Texas controller, we need not to write even a single line of code. So that's the advantage of this one. We shall open rotor initialization. Also, we have to open this block, this model. Since this being a permanent magnet synchronous mission, we need to initialize the rotor. So to initialize the rotor, we need to switch to hardware view. Then you run the model. Okay. Once you run the model, it will start to run. You stop it. Then you come here. You have to do one thing. You just delete it because this will integrate the reference input, so that the speed will increase gradually. We are not going to do that now. Just connect it directly. Okay, the reference value is 150 radians per second. So 150 radians per second is around 1500 rpm. Okay, so these are the blocks used for simulation. If you know the parameters of the motor, you can very well simulate it. And once you click the hardware view, this will get disappeared. Okay, so these are the blocks used only during the simulation, and during hardware operation these blocks will get disabled. Okay, so we are doing two things. One is controlling the PMSM motor, and in parallel to that we have one controller which will control the DC machine. So this is the DC machine, and this will get controlled by this PA controller. And this is the block which is responsible to measure the speed via the rotary encoder of PMSM, and this is the one which measures the current. And from the rotary encoder we are measuring the position of the rotor as well. So inside this we have the hysteresis controller. So we shall run the model now. Okay, yes. The motor is setting perfectly at 150 radians per second. So since we have given 150 as reference, the motor is running continuously at 150 radians per second. So as you can see, this time will increase as you click this. Simultaneously, you can see the current as well. Okay, thanks for watching.